We continue on with our review of factoring with our second homework set from college algebra. Factoring, again, first thing you always look for is the greatest common factor. Always. I don't care what anybody else tells you. Trust me. So, is there a common factor for all of these guys other than 1? The answer is no. Alright. Since it has 3 terms, I expect it to factor as 2 binomial factors. Now, look at the factors that you have for 4. 4 can break down as 1 times 4 or 2 times 2. 6 can be 1 and 6 or 2 and 3. Look for common factors among the factor pairs. I circle the 2 and the 2 because they have a common factor of 2. Does 2 go into the middle coefficient? The answer is no, so it means I cannot use this combination at all. So that means I'm forced to use 1 and 4 as a means of breaking down the 4x squared. I will use x and 4x. Now notice this guy here is positive, so we know that the signs here must be the same. Since I need to end up with a negative 11, I know that I must use 2 negatives. Now, in the previous video, I mentioned using the smaller factors first. You don't have to, but it's always a good idea to try those. Plus, smaller numbers means smaller numbers, right? If I try to use 2 and 3, I can't put the 2 here because I can't have common factors inside here if I took it out up here. So since there was no common factor here, I can't have it down here, so the 2 doesn't work. Let's try the 3. If I put a 3 here and the 2 here, does this work? Well, on the inside here, you get a negative 8x. On the outside is a negative 3x, and I guess we're just lucky today. So there's your negative 11x. So, well, I guess factoring isn't that bad. If you pay attention, you can avoid trying dumb combinations. Well, let's look at number 2. Is there a common factor for everything here? Well, no. I mean, it tries to trick you into thinking, oh, these first 2 guys have a common factor, but this last guy throws everything off. If you look at the factor pairs you have to work with for 12, 12 can be 1 and 12, 2 and 6, or 3 and 4. 35 is 1 and 35, or 5 and 7. So these are the only numbers that we can work with when it comes to factoring. Okay, trinomial, we expect it to factor as 2 binomial factors. Now in the last problem, we circled the 2 and 2 because they had a common factor of 2. Down here we can do the same thing. 2 and 6 have a common factor of 2. Does 2 go into 32? The answer here is yes. In the last example, this common factor did not go into 11, so I couldn't use it. But since it does go into 32, that means I should use this combination when I factor. So I'm going to do 2x and 6x. Now I need to end up with a negative 35, so I know the signs must be opposite, but I don't know exactly what they should be. So I'll come to that in just a moment. Now look here, if I try to use 1 and 35, I want you to see how this doesn't make any sense. If I try to put the 35 here, I'm going to have 35 times 6 and 1 times 2, which is going to be so far away from 32 it's not even feasible. Don't even try that one. If I try to put the 35 here and the 1 here, again, that gives me 70 and 6. No way I'm going to get to 32. So remember what I told you before? Start with the smaller numbers first. Now you can hopefully kind of see why. I just have to figure out where to put the 5 and the 7. And what you realize is that there is no contradiction if I put the 5 with the 2 or the 5 with the 6. Same thing with the 7. There's no contradiction. So you just kind of have to try something and see what happens. If I put the 5 and the 7 here, let's see what happens. That gives me a 30 on the inside and 14. Well, 30 and 14 does not give you 32. So clearly I've got to switch these guys around. So if I put a 7 here and a 5 with a 6, does that work out? Well, I think it does. On the inside here you get a 42x. On the outside is a 10x. Now, since we didn't know what the signs were, but we knew they needed to be opposite, that's a clue for us. To get a negative 32x means this guy had to be negative. And this guy has to be positive. So backtrack those signs. Where did you get the negative 42x from? 6x times a negative 7. Where did you get the positive 10x from? 2x times positive 5. And we're done. So if you pay attention to the tricks, you can make these problems work very nicely for you. Number 3. Now as we look at this, I see that these guys are all even, which means they have at least a 2 in common. But they actually have more than just a common factor of 2. They actually have a common factor of 4. So first I'm going to factor out that common factor of 4, and that leaves me with 2x squared, 11x, and 56 divided by 4 is 14. Just make sure that you have taken out the greatest common factor. Do these guys have anything else in common? And the answer is no. Even though both of these guys are even, the 11 throws everything off. Alright, so I still have a trinomial, and I expect this guy to factor as 2 binomial factors. 2x squared has no choice except to break down as 2x and x. 14 could be 1 and 14 or 2 and 7. Now, since everything here is positive, and these guys are going to be positive, it really limits my choices. If I try to use 1 and 14, no matter where I put it, I'm going to end up way larger than 11. So I have to use the 2 and the 7. The 2 is not allowed to go here because it would cause a common factor, and then we'd fail. So the 2 has to go here, and the 7 goes here. A quick check will show you that you have 7x in the middle, 4x on the outside, so 7 and 4 gives you the 11. So this guy is factored. Now we come to number 4, 7x squared plus 47x minus 14. These guys have a common factor of 7, but 47 is prime, so there is no common factor other than 1. 7x squared has to break down as 7x times x. I don't know about the signs except they have to be opposite, so one positive, one negative. Well, now we got to play around with the 14. 1 and 14 or 2 and 7. If you start with the smaller numbers like I've suggested, I'm going to start here with these guys. Now I can't put the 7 here because 7 and 7 have a common factor, so that won't work. So let's make this a 2 and let's make this a 7, see what happens. That would give me 2x in the middle, 49. Is there a way to take 49 and 2 to come up with 47? And the answer is yes. If I make this a plus 7 and a minus 2, you end up with a negative 2x, positive 49x, and there's your positive 47x that you wanted to have. So if we follow the tips, the tricks, the techniques here, we don't have to try a bunch of combinations. We can very easily see what the right answer is. Now the right side of this is where I get happy. This is my happy place. I like factoring binomials. Remember that when you're factoring, if you have the difference of squares, that factors as a plus b times a minus b. So for number 5, this is the difference of 2 squares. So it's the difference of x and 7 squared. So the factorization is just x plus 7, x minus 7. You may say, what about the middle stuff? Well, if you were to check this, you get a positive 7x and a negative 7x. Those guys cancel. So all you end up with is x squared minus 49. Even something like number 6 is still a difference of squares, but you have to know how to see it. If things look really complicated, stop and ask yourself this question. Can I see this as something squared minus something else squared? 4 and 25 are both squares. They're the squares of 2 and 5. And x to the 4th is the square of x squared. And you see something very similar to the other, or in the other term. 121 is 11 squared, 144 is 12 squared, and of course y squared is y squared. So what we're doing here is that we're writing it this way so we can clearly see that this is our a and this is our b. So that when I factor this guy, it's just 2/5 x squared plus 11/12 y, and then 2/5 x squared minus 11/12 y. So once you identify where your a and your b are, you just very easily match it up into that form, a plus b times a minus b. Well, look at number 7. You may think, oh, number 7 is just like 5 and 6, it's the difference of squares. But it actually is not. What we need to see here is that this is a difference of cubes. This is the difference of x to the third and 2 to the third. So what we see here is that we have a cubed minus b cubed, and there's a formula that we have for that. The formula is the product of a binomial and a trinomial, and it follows this pattern. A minus b, a squared plus ab plus b squared. So if you can identify your a and your b, in this case the x and the 2, that's just a matter of using this formula. So a minus b would be x minus 2. A squared, well, a is x, so this is going to be x squared plus ab, well, a times b is just 2x, plus b squared, b is 2, so b squared is 4. Now, a lot of times students will try to take this guy and factor it further, but it doesn't. It's done. Anytime you use the difference of cubes or the sum of cubes formula, you're done. You won't be able to factor that any further, at least not using real numbers. But that's for another video. So look at number 8. 8 is very similar to number 7. These guys are both cubes, whether you believe it or not, except instead of having a minus, this has a plus. So this guy is x to the third plus, if you know your powers, you know that 512 is 8 to the third. So this is 8y to the third. So when I'm trying to factor a to the third plus b to the third, the pattern is very similar to what we just saw above in number 7. Except instead of going a minus b, it goes a plus b for the first factor, and then this is a squared minus ab, but the last piece is always positive. Okay. Sometimes we use the acronym SOAP. Same, opposite, always positive. So even down here we have the same sign, opposite of what we see, and then always positive. So a plus b means x plus 8y. A squared is x squared minus ab, so the product of these two guys is 8xy, plus b squared. Well, 8y is my b, so if I square that, I get 64y squared. And just like in number 7, once you use this sum of cubes formula, you're going to be done.